The reason we study waiting line theory is cost. There is cost to the consumer and there's cost to the business providing the service. Let's take a bank, for example. They have 10 lanes available and they don't know how many lanes to open, but they know for sure that if they open one lane, the line will be very, very long and customers will complain. As a result, the firm will lose a lot of money. How? The customers may elect to take the money and move it to another bank. They may be less likely to recommend your bank, and so on. If they open a lot of lanes, in this case 10, we notice that the loss to the bank is $205, and that means the bank is losing a lot less by providing better service. So now the bank manager would like to provide more service, but would like to have an informed opinion or informed visual of how that works. Assuming that the cost to open each lane for service is $200, we populate column C with the cost to open one lane, 2 lanes, 3 lanes, and so on. And to do that, we will use a simple formula. We start with equal, and we pick up cell B7, and B7 has 1 in it, and we multiply that by 200, which is in cell D4. However, as we copy the formula down, cell D4 content is not changing, so we would like to lock that by doing an absolute reference copy, and that requires that we press the function key F4 on the keyboard. You see $2 signs on either side of the D column, and that means as you copy this formula down, the D4 is not going to move. That's the cost to open each lane. However, the formula will pick up 1, 2, 3, 4 as it goes along. So it's $200 in the first lane, and now we copy it down all the way, and it's fully populated. At the cost of $200, we notice that the minimum waiting line, or the cost associated with waiting in line, occur when we open up 3 lanes. Less than that, we lose. More than that, we lose. So the optimum, if you look at the graph, the optimum amount of lanes open that would reduce the service costs and the opportunity costs is opening 3 lanes. What happens if actually the cost of the lane is opening each lane is not $200, but let's say $400? So I'll change the content of cell D4 to 400 and watch the chart. So right now, because it's very expensive to open up the lanes twice as much, the ideal amount that will kind of balance the cost to the bank and the consumer goodwill is actually opening 2 lanes. Let's look at another example where the cost is not $200, not $400, but $100 to open up a lane. And if you look at the chart, it looks right now that we can open 4 lane and maintain a very good balance between the cost of the bank and the benefit we get from that added service.